time period, a student is investigating the motion of oscillating meter rule. Like this meter rule or a meter scale will oscillate. Vertical threads are there, a distance d is there, and he uses his apparatus shown in figure. The student ensure that the meter rule is horizontal. Like student want to make sure that this is horizontal. How would you check that the meter rule is horizontal? You may draw a diagram. So whenever, if a question is there, we want to identify that if a rule or a scale is horizontal, what we do, we measure a distance from both ends. We measure the distance from both ends. And when we measure the distance from both ends, if the distance is same, like example, say this is 8 centimeter and this is example 8.2 centimeter. So it means it is not horizontal because one side it is the height from one side of a bench is more than the other side. It should be same size, same height from both sides, then it is horizontal. If the sometime they ask how you can show that the meter rule is exactly vertical, in that case you will use a set square. Because set square angle is 90. So if the set square, like use a set square, if a set square fit into the space, it means the meter rule or the meter scale is vertical. Or you can also measure the angle using a protractor. You can measure the angle. If the angle between the bench and the rule is 90, it means that is also vertical. So if the question was about vertical, you will answer in this manner. But this question is about horizontal. So you will mention measure the distance from both ends, measure the height actually from both ends from the bench. If two ends have the same height, then the meter rule is horizontal. So this is a technique which we use to identify whether it is a horizontal or no. The next question, a student moves the stand so that the vertical threads are at mark as shown. Calculate, look, what is D here? D is the distance between the marking, like distance between the two threads. That is D. So student adjusted the left hand side thread is at this mark and the right hand side thread is at this mark. How much is the distance between them? What is the distance between them? So that is equals to 96 and the unit will be centimeter because it is a meter rule or a meter scale. So the unit should be in centimeter. Is it already given here? But I'm mentioning in case if they did not. So centimeter and millimeters are used. He twisted the meter rule a small amount as shown in figure 1.3. Then he let it go and this oscillate to and fro. If they did not mention here, for example, if they did not mention, you can write your answer in millimeter as well. But it's a meter rule, so maximum is about 100 centimeters, so it cannot be. If it was in it will be 9.8 centimeter. If it was in millimeter, you will multiply by 10. So both are acceptable. You can use centimeter or millimeter. As in this question is already mentioned. So the student measure a time for 5 oscillation. It was 3.63. Suggest why it will be useful to take a trial reading for this experiment. So like trial reading means like we should do the experiment one time and then to have an idea. So why it will be an advantage of having a trial reading? Yet we can identify the range because trial readings are mainly to identify what is the range, or using a trial reading, we will have a rough idea of what will be the time period. So if a question is there, why we like suggest why it is useful to take a trial reading of this experiment. So trial reading of any experiment, whenever a question is there, trial reading, the idea is that we can have a range, because when you have a trial reading, you did the experiment one time, then you did the experiment twice. So first time you call that you are taking a trial. You are just doing a trial. Trial reading means just doing the experiment one time without making sure that things are accurate or no. Like without checking other parameter, we just take a reading. We just have a try of the experiment to have a range. So if you remember, in a titration in chemistry, it is usually done like when we do the experiment, the first titration is usually known as a trial reading. Why trial reading? So you will have an idea that what amount is needed to react it completely, like a range can be determined. So trial readings, the main purpose of a trial reading to have a range of, to identify the range of answer. Like where likely we will get an answer or which range will get an answer. So example, if you did a trial reading and you're getting an answer like example 4.5. So it means the answer will be somewhat closer to 4.5, means it might be above 4.5 or below 4.5, but in this range. The main purpose of any trial reading in experiments is to identify the range of the value, like to identify what will be the likely value for the experimental results. Is it clear, this one?
Yes, sir, clear.
He took a trial reading for this experiment. Even if he did a trial reading for one oscillation or 5 oscillation, that is does not make much difference. Like if he did the experiment as he's measuring for 5 oscillations, so he will take a trial reading for 5 oscillation. The student carry out the same procedure for different values of a D, 20, 30, 40, 50, 60 centimeters are there. You have, and this is a table. And how many oscillations are there? You can see the distance D for 20 centimeter, a table is there. And where T is a time for one. The value is for, in the equation is for 5 oscillation. How to get the time? They mention use the value of a T and the equation that 1 over T is equals to 5 by T. 1 over T is equals to 5 by T and determine this. So how much is this value? So how to identify as 1 over T is equals to 5 by T. So this will be 5. And how much is T? 17.85. So 5 divided by 17.85. What's the answer? 0.28. Okay. So we have the results. We have the results for, because the next part we have to plot a graph between D and 1 over T. So we have 20, 30, 40, 50, 60, and we have 0.28, 0.44, 0.57, 0.72, and 0.88. Actually, why the 5 is above? Look, T is what? T is a time for 5 oscillation, which is like time for 5 oscillation. If I need the time period, so time period will be the total time divided by number of oscillation. But if I need 1 over time period, if I need reciprocal of the time period, so this relation will also be invert. So it will be 5 over T. That's why 5 over T is written. Because we are finding 1 over T, not T. The reciprocal of the time period. Now we have to plot a graph. So they mention D should be on y-axis and 1 over t on x-axis. But here they did not mention you should start from origin. So we can, like you should not include the origin. They did not specify. So we have to use the origin here. So D is there. D is there. And how to label the axis? So write the quantity slash the unit. Then on x-axis, as you can see on x-axis, they mention 1 over t is there on x-axis. So 1 mark is for labeling the axis. So 1 over t slash 1 over second. And it is very easy to label the axis because even the units of the axis is given, like d centimeter and 1 over t is 1 over second. Now we mark the points. So as I did not mention, start from origin. So example, this is 0. Then we have minimum value is 20 and the maximum is 60. So we have to complete within 60. So 1, 2, 3, 4. So this will be 10. 20. 30. This will be, so it won't, because I will have like 10, 20, 30, 40, and so it won't complete. Yeah, in the question, as they did not mention anything, you should start from origin or you should not include the origin. So you can start with any number. I can start with even 20 as well. I can start minimum value. So I can say this is 20. This will be 30. This will be, I was just checking if I start with origin, whether it will affect or no. That I was checking. 40, 50 is there, and this will be 60. This is 60. And the last one will be 70. So if they don't mention, you should start from origin. You can start with any number, the minimum value you can start with. And same thing for x-axis, for the x-axis. Example, if I start with 0.2, because the minimum is 0.28 and the maximum is 0.88. So 0.2 after 5 boxes, 0.3 after 5 boxes, 0.4, 0.5, 0.6, 0.7, even and 0.8. I should cover about 70% of the axis. So it's about 70%. I can stretch the axis. If I stretch like if this was 0.2, then 3, 4, 5, it won't finish at, because 8 it is there. So this will be 0.8, 0.9 and 1.0. Now we mark the point when D is 20, 1 over T is point. So D is 20. So D is equals to 20 and this is 0.28. So 20 and 0.28 will be here. Then 30 and 0.44. So 30.44. Then 40 and 0.57. Just let me confirm. Yeah, 0.57 is there. So this is 0.6 for 40 and 0.57. This is 0.58. So 0.57. Then 50 and 0.72. This is 0.7. So this will be 0.72. And 60 and 0.88. So 0.9, this is 0.9. This one is 60, so 0.88 will be here. Now what we have to do, we have to draw a line of a best fit. Line of a best fit means the number of the points above and below the line should be same. So we'll try to maximize, like the points above and below are same, or maximum points are coming on the line. So this looks a line of best fit, like 1 point is above, 1 point is below. Now, after drawing the line of best fit, determine the gradient and show clearly on the graph how you obtain the necessary information. How to work out the gradient? You can take any 2 points of your graph. So example, I took this as the first point. The first point on x-axis, that point is known as x1. So we mark a point and you have to draw these lines on the graph. You have to draw this line because there are marks to show. So 0.4, this is 0.4. So we have the first point on x-axis, that is called x1, which is equals to 0.4. First point on y-axis is called y1. So it is like 7 boxes above 20. So that is 27. Same thing, take any other point. So we'll take a second point. The second point on x-axis, that's called x2. This is 0.8 after 0.82 boxes. So that is 0.82. X2 is equals to 0.82 and y2. So 51, 2, 3, 4, 5, 6. So 56. So y2 is equals to 56. How to work out the gradient? The formula for gradient, you have to learn that y2 minus y1 divided by x2 minus x1. So y2 is equals to 52. Y1 is equals to 27. X2 is equals to 0.82 minus X1 is equals to 0.4. Better solve numerator and denominator separately or like 52 minus 27. So that's equal to 15 and 0.82 divided by 0.4. That's equal to 0.42. So 15 divided by 0.42. What's the answer for gradient? 15 divided by 0.42. Oh, sorry. Yeah, that's right. 25. Yeah. By mistake, I calculated 25, but I wrote 15 there. 52 minus 27 is 25. That's right. So 25 divided by 0.42. 59.6. 59.5. So gradient is equals to 59.5. Is it clear how to work out the gradient? Anyone having a doubt? Then explain why it is. So this is a question they repeat many times. As you can see, explain why it is more accurate to measure a time for 5 oscillations rather than 1 oscillation. Like why we measure a time for 5 oscillation, why not only for 1 oscillation? So what is the effect? It will reduce, yeah, we'll get an average result, or it will reduce the percentage uncertainty. Like uncertain, we will be certain in our values, like percentage of uncertainty in the result will be reduced. TAINITY. TAINTY, so uncertainty. Then the next part is describe how the experiment could be improved to make the reading more reliable. If we want to do it more reliable, how we can increase the reliability of the results? What we should do? So we should repeat the experiment with greater number of swings, like repeat the experiment with 20 oscillations and take an average. Repeat. Experiment with more oscillation or with 20 oscillation. And we should take an average. Like repeating, it's not like doing the experiment one time, doing the experiment many times and then they take an average result. Like you did the experiment one time, you got the time as 20.1. Then we did another 20.3. Then we did another, say 19.8. Then we did another, say 20.4. So what we should do, we should take an average result. Like do the experiment multiple times and take an average result to be more accurate.